No, he didn't. All right, hey guys, we're on example 2. I erased all my stuff from example 2 because we're going to start them from the beginning because people are like, I forgot what we were talking about. All right, so here's the deal. Here's the diagram. You will not be given this for your homework assignment, but this is what he looks like just so you can check your answer, right? What we're ultimately trying to do is this is the graph of, and now he came back. Oh, Rem was here. I see. Did you guys see that where it said Rem was here?
No.
Thanks, Rem. All right, here's the graph that we're starting with of y equals 2 over x. That's what we're starting with, this blue curve, right? And I have picked this point, which is the point 2, 1, and I want to know the equation of the line that is tangent to that point, all right? So when we're doing the equation of a line, we need to know what y equals mx plus b, right? And we have to find the m and find the b, okay? But how do you find the slope of a line if you only have one point, right? So what we do is we talk about like, okay, let's take a point right here and let's find the slope of that, right? That's not going to give us a very close slope to what this one is, right? So let's take that point and let's slide him closer, right? That's going to give me a better slope, true? Okay, let's slide that point even closer. That's going to give me a better slope, true? And I keep sliding this point closer and closer and closer till I still have 2 points that are almost identical to each other, right? Okay? And what that's doing is that's called a limit. So what we did before was we did the limit as x approaches our x naught. And our x naught is the point that we're looking at, right? The point 2 that we're sliding closer and closer to. We want to know if our dot, which is x, is getting closer and closer to that value of 2, like what the slope will be, right? The slope is f of x minus f of x naught over x minus x naught, okay? This is y2 minus y1 over x2 minus x1. So we're taking our point and we're sliding it closer to that x naught value, which is 2, okay? And then we're plugging this in and we're finding the limit because this guy is going to give us the derivative, okay? And a derivative is the slope of the tangent line, okay? So this guy will give me m for my equation for my tangent line, right? This is what a derivative is using this limit function, all right? So that's the formula. I've got the limit as x goes to, x naught was 2, right? And now I'm going to plug stuff in. So f of x is another way of, a fancy way of saying y, right? Okay, so f of x is 2 over x. So I'm going to replace 2 over x on that guy. 2 over x minus f of x naught. What did we say x naught was? No.
2.
X naught is just 2, right? Okay, so f of 2 means I'm plugging 2 in here, which is 1, right? 2 divided by 2 is 1, so that's where we get that point right here. X on the bottom is just going to chill and stay x, and this guy, x naught, is 2. So now we have that stuff plugged in. We plugged numbers in for x, f of x, f of 2, and then 2 in for x naught on the bottom, okay? Now, I'm trying to evaluate this limit. Can I plug 2 in? No. So what I do instead is I try to simplify him, all right? I don't like that I have a fraction here and a whole number here. So what we're going to do is we're going to try to get a common denominator. So I'm going to make this 1 x over x. You see that? Yes, this is a review. We did this yesterday, okay? So I'm going to make him x over x. Now, if I put these together under one roof, this will end up being 2 minus x over x. True? All over x minus 2 over 1, basically, if I make him into a fraction on the bottom, right? Now, let's keep flip him to the top. So I'm going to do 1 over x minus 2. It would be really super nice if I could cancel these out, but x minus 2 is not the same thing as 2 minus x. Unless I take negative 1 out of this guy. If I pull a negative 1 out of here, this will be x minus 2. True? Yeah?
Yeah.
So then, this x minus 2 will cancel with that x minus 2. And all I have left is negative 1 over x. True?
Yeah.
And I'm finding the limit as x goes to what? 2. So now I can plug the 2 in. Negative half, right? Negative 1/2 is the limit. And that tells me the derivative, which is the slope of my tangent line, right? Slope of my tangent line. So now I am at the point where I have y equals mx plus b, but I know that m is negative 1/2. True? How do I find b?
You just go back.
I'm going to plug in x and y, which is 2, 1, right? Okay? 2 goes in for x. 1 goes in for y, right? So I have 1 equals what's negative 1/2 times 2? negative 1 plus b, so b will be, b is 2, right? So my equation of my line is y equals negative 1/2 x plus 2. Check it out. Did we do it right? Negative 1/2 x plus 2. There he is, right?
Yeah, you can see it on the graph.
You can see it on the graph, right?
You go back.
Like, that's the answer. That's how we check our answer, right? Yeah? Okay? So, in order to be able to find that slope, because we only have 1 point, we do it as a limit instead, right? And then we, like, adjust the limit and stuff a little bit, right? Okay? Good, good? All right, let's do, this one is just saying find the slopes of the tangent lines. Slope of tangent line is derivative, and the derivative is using that limit formula, right? Okay, so I want to find the derivative using the limit as x goes to x naught of f of x minus f of x naught over x minus x naught. That's what we're going to be doing every single time, right? Okay, but so they want me just to find the slope. They just want me to find m. They don't want me to actually plug it in and do y equals mx plus b, right? They're just wanting me to stop at m, but they're wanting me to do it for 3 different points. 1 when x is 1, 1 when x is 4, 1 when x is 9, okay? Let's see how the first one goes, and we'll see how much room we have. Then we'll do the other ones if we get a chance to, right? So I'm trying to find the slope of this tangent line, right? But I can't find a slope unless I have 2 points. That's why we do it as a limit. Got it? Okay? So I'm trying to find the slope of that line. All right, so here we go. If I fill stuff in, the limit as x goes to, my first x naught point is 1. So I'm going to plug 1 in there, right? F of x is the square root of x, right? That's my equation. F of x is the square root of x minus f of x naught. What's f of x naught going to be? 1, right? The square root of 1, which is 1. Over x minus 1. Got it? Okay. All right, now, this is kind of funky weird. Can I plug 1 in?
No.
No, right? So what strategy do I use on this?
For everything.
Difference of squares.
What do you do when there's a square root involved?
Radical, unradicalized.
You rationalize, okay? So the thing that I have a problem with is the square root, right?
Oh, times the
Yeah.
So I'm going to multiply by the conjugate. What's the conjugate going to be?
Oh, yeah.
The square root of x plus 1 over the square root of x plus 1, right?
That's what I meant, but
Okay.
I didn't say square root.
So when we do this, I'm going to get rid of my m right here, okay? When we do this, I've got on the bottom x minus 1 times the square root of x minus 1. I'm not going to FOIL that out, right? But on the top, the square root of x times the square root of x is just x. Then I've got my middle pieces, which would be like plus the square root of x minus the square root of x. Those guys are going to cancel, true? And then I've got negative 1 times positive 1, which is minus 1. So on the top, I have just x minus 1, because my middle 2 pieces cancel.
Put 1 over it.
Oh, hey, check it out. Do you see what it is?
Yeah.
Those cancel. So what I have left is the limit as x goes to 1 of 1 over the square root of x plus 1, which is 1/2. That's my slope, right? Does it look like the slope here is 1/2? Hey, check it out. Slope is 1/2.
What is that? I don't know what you're looking at.
I'm so confused.
You're so confused?
How is it half if it's 1 over?
You plug
the square?
it in.
What's this?
You plug 1 in right here.
One
So
plus
if you
one
see
is
that,
2.
instead of going to all that work, why not just flip it and put x?
What?
Like, can't you skip
Just
all that?
rotate.
Maybe.
Like, if you know you're gonna multiply by a conjugate, can't you just put the opposite thing on the bottom, put 1 on the top?
Maybe, sure. I don't know. Maybe.
That way you don't
But maybe not all of it will cancel, though.
What do you mean?
I'm gonna just
Not
do
all
it
of
this
will
way.
Okay, let's do 4 because I have room for 4, and then, or should we do 9?
Sorry.
Should we do 9?
Yeah.
Let's do 9. We'll skip 4, we'll do 9, all right? So I'm doing the limit as x approaches what? 9 of f of x. What's f of x going to be?
3.
Nope. What's f of x?
Square root of x.
The square root of x. What's f of x not?
81.
No.
No.
9.
3. The square root of 9, right?
My bad.
Which is
Why
3.
did we split
What?
it?
Yeah.
Right?
That's
So
square root.
f of x naught means I'm plugging my x naught, which is 9. So it's saying f of 9, right? So that means I plug 9 into there. And that comes out to be 3.
Because
Yeah, yeah.
and f of x are the same thing, they just did it stupid.
Correct. Over x minus x naught, which is 9, right? Okay, can I plug 9 in?
Yes.
No.
No.
Yeah,
You have to
you-
do the
No.
reciprocal.
No, you'll have 0 on the bottom.
Conjugate.
Okay.
So I'm going to multiply by the conjugate, which is the square root of x plus 3, and the square root of x plus 3. Sure.
So why skip?
Okay, on the bottom, I've got x minus 9 over the square, because I need to multiply by the conjugate of the square root stuff.
But you know it's gonna be 1.
Okay, so I've got that going on. All right, the square root of x times the square root of x is x. The square root of x times 3 is 3 square roots of x minus 3 square roots of x. That goes away. What's the negative 3 times positive 3?
Minus 9.
Minus 9. So this whole thing is going to cancel with that whole thing.
Yeah.
So I end up finding the limit as x goes to 9 of 1 over the square root of x plus 3. If I plug 9 in now, he is 1/6. Is the slope at 9 equal to 1/6?
Nope.
Yeah? And the 4 would be the same, right? It would be 1/4 because we would end up doing that, right? Okay? Happy with that? You see how this works?
But it already told us
When-
that.
Right, but you won't have this on your homework assignment. The only reason I put that on there was so we could check, right? So you could see what it was that we were actually doing, right? It makes a little more sense having the graph there, right?
Is there always going to be a pattern like that?
For those, yeah.
It's a character one.
Yeah? Good? Okay, here we go. Let's go like this, okay? Yesterday I talked a little bit about the difference between the average rate of change, and instantaneous rate of change. Okay, we talked about the difference between those two. Average rate of change versus instantaneous rate of change, right? So like, let's say I have a function that's like doing something like this, right? Average rate of change would be my average displacement from one to the other versus instantaneous rate of change is like, how fast am I going at that exact point, right?
Teacher, you drew a car.
Average rate of change versus instantaneous rate of change. I have no idea. Okay, cool.
Snowplow.
All right, so let's go to example 4. Here we go. Suppose that this is my position function, so maybe that's the height of a particle that I have
Why did they write it
that's
like
being
that?
thrown, and they wrote it like this because they just did weird things, right? So what does this thing look like, by the way?
That looks
What's
like
his
a-
parent function?
Complex trinomial.
What's his parent
it's
function?
right.
He's a t squared, but he is a negative t squared, right? So it's going to be one of those, right? That's what we have going on here, right? He is a parabola that's going downward, all right? Where s is in meters and t is in seconds. Okay, now, be very careful of the notation that they use. It says find the average velocity or the average rate of change. What's another word for average rate of change? Slope, right? So y2 minus y1 over x2 minus x1. They're having us find the slope from point A to point B over the interval from 0 to 2. The way that it's written like this is like interval notation. So
Yeah.
what it's saying here is that
Everything
your
from 0 to 2.
x1 is 0 and your x2 is 2. Is that confusing?
No.
Some people think this as xy. That's not how that works. Your
Because it's
interval
exact.
notation is x1, x2. Got it?
Yep.
Okay, so that's part A, and then part B, they're going to switch and have x1 be 2 and x2 be 3, right? So we're going to do this problem twice, okay? They want average rate of change. Here's my equation. Now,
Can we rewrite
no,
that? non-stupid?
no. Now, I don't have y's. I don't have a y1 and I don't have a y2. Plug them in, right? My formula is 1 plus 5t minus 2t squared. Did I write that down right?
Yeah.
Yeah. Okay, I don't know. Sure. Negative 2t squared plus 5t plus 1. Sure, if we want to write it the correct way. Woo. Okay, that's that. All right. I'm going to plug in 0. What do you get when you plug in 0? 0, 0. You get 1. So y1 is 1. Whoop. Put that in there. 1. If I plug in 2, 2 is here, 2 is here.
8,
This is negative 8 plus
3.
10 plus 1. So y2 is 3. Shall we go ahead and do it for part B because we're going to have to do it anyway?
Yeah.
2 is
3.
3, right? We already plugged it in. But now we have to plug in 3. So negative 2 times 3 squared plus
0.
5 times 3 plus 1, right?
0.
This is negative 18 plus 15 plus 1.
You mean,
It is-
You mean y1?
Negative 2.
Oh, yeah, that's y1, right? y2 is going to be negative 2, right? Okay? All right, so there's how that works. Okay? Now they want the average rate of change. So what do I do now?
You do math.
What's average rate of change mean?
X's over Y's. and stuff.
Slope.
Slope. We're just doing the slope of those, right? We're doing the slope of these guys. Average rate of change. So how does it change when it's going from 0 to 2? Is it going uphill or downhill as it goes from 0 to 2? It's going uphill, so my slope should be going up, right? y2 minus y1 over x2 minus x1 is 2 over 2, which is 1. It is going up 1 over 1, up 1 over 1, on average from 0 to 2, right? On average from 0 to 2. What?
From the interval.
From the interval. 0, from 0 to 2. Okay? Yeah? Okay?
So you're gonna have to find the average for all of them.
I'm sure. This one's going from 2 to 3. So from 2 to 3 seconds. At the 2 to 3 second mark, is it going uphill or downhill?
Downhill.
My particle has turned around and is starting to fall back toward Earth, whatever, right? Because it's doing the parabolic motion, right?
Yeah.
So it's falling toward the Earth from between 2 and 3 seconds, okay? So if I do y2 minus y1 over x2 minus x1, it is negative 5 over 1. So it is going faster, but it's falling toward the Earth. It is going negative 5 whatever units per whatever unit per second. Units per second. Meters per second. Right. Is that what we're in?
Yeah.
Find the average velocity. Oh, it says say meters. So this is meters per second, and this is meters per second. Okay? So between 0 and 1 and 2 seconds, it is averaging 1 meter per second, right? If we're going from 2 to 3 seconds, it's falling toward the Earth faster, 5 meters per second, but it's negative because it's falling toward the Earth. Got it? That's how that works. That's average rate of change. We didn't even use derivatives or limits or anything like that in that problem. That's straight like trig stuff we could have done, right?
That was like algebra stuff.
That was like algebra stuff we could have done, right? Okay? Good?
Yeah.
All right. Consider the particle. So we're going to do the same equation again. Listen.
Do you like it?
Oh, right in the middle.
What was that for?
Who's it for?
You get that from the back?
Mine's the back of the dryer.
Tomorrow.
Okay? Here we go. All right. Consider the particles. So example 5 now is going to take into consideration what we were doing with the limits above. So now we're not doing the average rate of change from 2 to 3. Now I want to know at the very instant where I'm at 2 seconds, how fast is that particle going exactly at 2 seconds, right?
Let's find it out.
And instantaneous rate of change is like a slope, right? But it's instantaneous, but I have to have 2 points. But I want to know exactly at 2, right? So like how do I do that? I do that limit thing, right? The limit as x goes to x naught of f of x minus f of x naught over x minus x naught. All right, what is x naught? 2, right? X naught is my 2 value, okay? So I'm going the limit as x goes to 2 of, what is f of x?
The negative.
Holy moly. What is f of x? 1 plus 5t minus 2t squared. That's what f of x is. That's this guy. Holy moly. What's f of x naught?
Yeah, we gotta plug it in.
Is what I get when I plug in 2. We already did that up here. What we get when we plugged in 2?
3.
What we get when we plugged in 2?
3.
3.
Well, it tells you in the
Yeah. I mean, it does.
right there.
Yeah, it does tell you in the problem, I guess. Okay. Over x minus 2. That's what my stuff is, right? Can I plug 2 in? No. Okay, so let's simplify this top guy here and let's see what we get, right?
Complex trinomial.
He is, you think? Okay.
But it doesn't
So I'm going to go negative 2t squared plus 5t minus 2 is what we get over x minus 2, right? That's the limit as x goes to 2 if I simplify him, right? Okay. So we know we can't plug him in, right? Let's see. Did I do what?
She combined.
Well, she
No, I
combined-
combined them. Yeah?
They say shooter shoot.
Right? You see what I just did? I combined them? No?
I think
Like this guy, and I took the 1 and the 3 and I combined like terms, right? Yeah? What?
Are we simplifying the top?
Yeah, we're going to make him a complex trinomial.
Hey, can we try this? Can we go negative
Well, maybe
2t
there's a holder right there.
plus 1?
Well, there probably is a hole.
What are you
We
talking
don't
about?
Care.
Try negative 2t plus 1, and then parentheses t minus 2. Someone do it.
No.
Wait, are t and x the same?
What? Yes.
T and x. Is
Oh, yeah. What did my variable switch? I'm sorry. Yeah. This should actually be the limit as t goes to 2 instead of x. Yeah, t and x are the same thing. I'm using the wrong variable. This should say as t goes to.
Let's factor out the x
Okay.
minus 2.
So let's do this as this is a t,
Well, is it?
and this is a t.
Yeah.
Let me fix
Why
this.
don't they go
T,
pink now?
t. I'm sorry.
So is it like?
So this is a complex trinomial. Let's figure them out, right?
Negative 2t plus 1.
Hold on. Negative 2 times negative 2 is positive 4. What do you get when you take 4, multiply to get 4, add to get 5, right? Okay, so I'm going to do it over here. So negative 2t just chills. Minus 2 just chills. Plus 4t plus 1t, right? And now I'm going to, like, group, right? Group. What are you going to pull out?
Can you,
Negative 2.
Negative 2t. And leftover is t minus
2.
2. What are you going to pull out the second piece?
Positive 1.
1. And leftover is t minus 2. So this group right here, if I do that, he is t minus 2 times
I said it was
negative 2t plus 1. Right? And the bottom is t minus 2. And I'm doing the limit as t goes to 2. And if I cancel those out,
Then you just plug
now can I plug 2 in?
wait, you're going
So-
too fast.
I'm going too fast.
She's not. She's going too slow.
Trevor's the one who's
Okay,
slow.
okay. So this is a complex trinomial. All we did was factor them as a complex trinomial over there, and we got those two.
Yeah.
Right? Yeah, yeah. Okay. So now after I get rid of him, I have this going on, and negative 2t plus 1 is what's left over after I get rid of all the things, right? And now I'm going to plug 2 in. Whoop. So he is what?
Negative 3
Negative 3. Negative 3 what?
meters per second.
Meters per second. So at a time of 2, he is going negative 2 meters per second as a velocity. So he is actually going downhill.
He's
What?
being thrown off the
Negative 3, I'm sorry, negative 3 meters per second, okay?
But
So
it's-
right here, you can see right here that this guy, his slope is negative 3 meters per second, because he's going down 3 over whatever, right?
Stop.
Where'd you get
Does that make sense?
Yeah.
Instantaneous would be the slope of that tangent line, right? Instantaneous rate of change. Not the average rate of change from something to something, the instantaneous rate of change.
Can we do homework?
Got it, got it?
Yeah.
Yeah.
Yeah. What's the homework?
Yeah. Okay, so start the homework. You should be able to do maybe the first 3. There's five problems. So 2, 12, 16, and then 26, 28 we'll do maybe tomorrow. But try 2, 12, 16. Got it?
Wait, show me this.
What? Actually, it's 3. 5.
Obviously not.
I was taking mental reps there, not physical reps.
Exactly.
Sure. All right. Goodbye, people watching the video.